Good evening. Welcome to this episode number 12. Ozzy has done 12 episodes of this game related to the game of Ozzy, the racing car game, and as I was saying, it is episode number 12. Let me unmute Ozzy. Hello, Ozzy. Welcome to the
Hello.
club.
Bonsoir. Good evening, good night, depending where
Hello,
you are.
Gary.
12, and you have to add all the other streams that are not related to the game.
Yeah. I mean, 12 related to the game, I was saying. Yeah, there are another 7 of the 7 or 9, 7 of the demo stuff. Yeah.
So right now I'm a seasoned streamer. I can have the badge of the Twitch streamer.
Yeah. So we continue with the game that Ozzy has done. He has some advances. He made some advances in the game, which we will see them in a minute. But first, as always, let's go to my usual thing. There we go. So guys, please like and subscribe to my YouTube channel. It's the only way I know of how to share my videos. Also remember that under each video there are links related to that video. For example, to Ozzy's source, there will be, if it's an Ozzy video, I mean related to the game dev that Ozzy is doing or the demo, there will be the code that was there for that episode. It's different than what he has on GitHub. So on GitHub he always has the latest version, no? Although you can go backwards, I assume. But here is the code specific to that episode.
Yeah, I give the source tree where you can navigate with Git checkout.
Yeah. But what I mean is the code as it was for that episode, because it's difficult to know what was the code for that episode. But yes.
Exactly.
Yeah.
As a checkpoint.
Yeah. So yeah. And the code will be on Mega. You'll get, if you are just trying to get access to the code, basically you have to go to Mega, to my shared link, and you get code related there, related to the videos. Of course, there is code that I do not share in there, which is not public, but is on only with my Patreons, and that is also on Mega, but it's in another area. I remind you that I have my Facebook page where I use as my blog, and I also have my Facebook group, the Phase 101 Facebook group, and as you can see, there are people sending me messages which I haven't read yet, but yeah. Same thing, there is another group, Commodore Dev. This is constantly growing, always updated, so please go there to see anything related to Commodore. So subscribe, follow, whatever. As I was saying, you can send me messages on Facebook. I do take my time to read, but if you send me messages on YouTube, if you send me messages on Discord, so please join my Discord, I will reply much more quicker. If you don't like Facebook or Discord, you can always join my Telegram group. In the end, if you want to support us and help us, everything that you donate goes back to the channel. Then you can either subscribe to Patreon or Ko-fi. For both of them, you will unlock 116 videos related to game development, not game development, because it's both. And these are not shared on YouTube, these 116 videos. And as you can see, there is also coffee. I have to remind you also about the Retro Tank game jam that we are doing, myself and Retro Programmers Inside. So you still have 1 month, 10 days. It's still okay to do a game, whatever language you like. But the date is getting closer and closer, no, to finish the game. I am behind, so I'm not a good example of this, but yeah. And also I remind you that all the games go on Retro Programmers Inside itch.io page. Those that were published, though, those that if the person that did the game doesn't want it published or is still enhancing it, they will not be there. So let's go to the slides that Ozzy prepared. Hello, Z3K. Hello. How are you? Hope all is fine. Thanks for the follow, Z3K.
I think I know this guy.
Yeah, we all know this guy. We both know this guy. I get a Meg. No, you cannot. It's a good joke though. Oh, hello, Dockster. I missed you, Dockster. So yeah, Ozzy, you can basically start.
Stage is mine.
Yeah.
Okay, so I don't know where to start because I was distracted actually. But yes, this is, let's say, a continuation from what you saw last stream. And just as a refresher, my goal now is to implement some sort of logic into the game that applies to the cards, and I want the CPU to be able to drive the car, more or less, at least something that reminds a human, even if it's still very bad. So if you remember last time, I was able to perform a seek operation. It means I have a point in the track, I have a car, I showed some math, some formulas, how to point the car toward this destination point, this hotspot. I call it hotspot. And what you saw last time, it was just Prince Phase was just setting a variable in the code which represented the coordinate of the hotspot, and the car was able more or less to reach this point and find a quite short path. Not the shortest, but it was something good for me at least. So it means that the seek function was stable enough to try to do something else and try to make this car move throughout the whole circuit and complete a lap without being interrupted or being stuck in some corner of the track. So in this stream, I will just show what I did in order to accomplish that. And still, it's not perfect. And still, the game is very easy to beat because still it was my goal was to have a multiplayer game, so something that you could play with your friends, with other humans. It was not meant initially to compete with a CPU car. So this is just a bonus feature, and I liked to implement, but it was not really what I had in mind when I started back last fall, last autumn. So I'm pretty satisfied with the result, even if it's very easy to beat the computer. We will see if Phase is able to do it. I think yes.
I haven't even tried the
Okay,
game.
go to slide number 1, and but I think I just explained
Yeah.
everything. Let me check. Oh, okay, this slide number 1. This is just a little reminder about last time. It was not last week. It was 2 weeks ago, I think.
Yeah, 2 weeks.
So at a certain point, I showed how I calculate square roots, and I think it was ProtonFig that chimed in.
Yeah.
And it was very appreciated, because when I say, okay, I had a problem, I found this solution, and if someone gives me a better solution or still another solution, I'm very pleased. So thanks to ProtonFig. And I took his code and I put the code into a bench. And the bench in this case was Easy68K, which is a software that runs on Windows. And you can inject your assembler code into it. And he has this very cool feature. He can count cycles. So it's, of course, there is, in order to compute speed in the game, there is something more to analyze, but still, this software is very good from my point of view, in order to just have a rough estimate of how slow or how fast is your code. And here I built, I didn't provide the screenshots from Easy68. Okay, so I hope you will trust me for this data. But I built this little Excel spreadsheet, and I have on the first column there is the radicand. So let's say I want to calculate to get the square root of this 40,000 number, and in the following columns I put the output of my routine compared to the output of ProtonFig routine. And also I put the cycle counter from this program, this Easy68K. And the results, the outcome was quite astonishing, because my routine, of course, I would say it's more accurate, because I'm using pre-calculated tables, but this comes with a very high cost. I had to use 64K of chip RAM in order to build this table.
And why still, chip RAM? Why chip RAM? Why not Fastman?
Because I don't have fast on my test machine. I just using chip RAM. Mm-hmm. But yes, it could be allocated on Fastman if you have.
Yeah, sure. I just asked because I find it.
Yes.
Yeah.
And what I was saying is that when you program on the Amiga, often you have to choose between two different roads. You have to say, okay, I want speed and I want accuracy, and I'm willing to give RAM for this. Or instead, you want a little routine like ProtonFig did, and this is the way to go. So I'm not saying that my routine is better or ProtonFig routine is better. It just depends from what is the situation, and it's up to you to pick the right one. And interestingly, I noticed that the routine from ProtonFig takes more cycles with smaller square root. So, for example, if you ask Proton to calculate the square root of 1, which is quite trivial, it's row number 7, and in order to compute 1 and the result of this routine is correct 100%, but it took 600 cycles. And I don't know why it took so long. On the other side, if you feed his routine with a pretty high number, for example, 80,000 or 200,000, so a very high number, I see that the cycles are much less. And I didn't go into detail analyzing why this occurs. Probably the cycle, there is a jump in his routine that cycles through. I don't know what's the math behind this, but yes, I noticed this strange behavior, and but still, the solution is very good. Also, the accuracy, if you notice, the accuracy is quite good. We have, for example, at row number 6, I was asking to calculate the square root of the number 123,455. And of course, my routine was quite accurate. The only 1.3 was the difference between the result and the correct result. And ProtonFig, it was a little bit more. But still, for me, these are situations. So all these numbers are usable. So even if it's not the correct answer, the correct result, it's something that it could be used on a game like mine, because the user won't notice if the car is not heading to the very precise pixel. So for me, right now, I'm still using my version because it's faster. But yes, keep in mind that there is this quite nice alternative from Proton. Okay, so yes, this is just like a subtopic for today, just a follow-up to what happened to last stream.
So I'm curious in the end, what did you use? Your routine or that of Proton?
I still use mine because I still have cheap RAM available. If tomorrow I run out of memory, I will replace the routine with the one from ProtonFig. For sure. Right now, mine is better because even if I'm using a lot of memory, if you can see, it's faster.
Yeah.
Even if I have to fetch
this is a good test
memory.
what you did. And you said you used the EC68K, you know?
Exactly.
Yeah.
That's
a good
spreadsheet
test.
Was built using this the EC68K.
It's a good test. Yeah. Okay.
Yeah, I would say it's accurate.
Of course, definitely it is. Yeah.
You have to do other consideration, of course, in terms of speed. For example, my routine is taking data from RAM, and when you transfer data from RAM, you are taking some extra cycles.
Yeah.
Maybe you are preventing the splitter to do something, or so it's quite complex. But still, the difference is quite big because, for example, in my first test, I just used 74 cycles compared to the 386. So it's a quite speed advantage. And you remember that you have to always multiply the difference of the cycles for each car, for each frame. So even if the difference is quite small, you also have to consider that it's repeated over and over again.
Mm-hmm.
So this is why I'm sticking with my solution, and it works fine, even gives better results, of course, because I'm using the table. Another disadvantage of my routine is that I'm trashing some data register. I think A0 is trashed for sure. So in order to use my routine, you have to save into the stack or in some other register the contents of A0 if you need them. And instead, ProtonFig is trashing only, I think, D1 or D2, I don't remember. I think it's D1. But yes, still, for now, I will stick with my solution. But anyway, I publicly thank ProtonFig for his contribution. And that's it.
Yeah, I changed it to the next page.
Yes, I can just give a brief description of the changelog, what I did into these last 2 weeks. Then we can show the game if you can compile it. Otherwise, you can just run.
No. I managed to compile it while in the stream, so it's fine.
So changelog.
And not compile it, assemble it.
Assemble, pardon. Yeah. Yes, it's different, of course. It's different. It's not the same.
Yeah.
So CPU cards are now able to follow a path, and this is my primary objective, my primary goal for this week. I decided to disable the collisions between cars when the race is over, and this is why when the car crosses the finish line, the car, you can't move the car anymore.
Yeah.
So if you have a lot of car crossing the finish line, the road is cluttered with cars, and maybe who is coming, it can't cross the line because they are blocking.
Can I stop you a second regarding collisions? Are you using hardware collisions or software collisions?
No, I'm not using hardware collisions.
It's software.
And I wrote my own routine.
Yeah.
And the reason is because the Amiga hardware gives problem if you are trying to detect a collision between sprites which are into the same couple.
Yes, yeah.
And this is one of the reasons. The other reason is the Amiga hardware is just telling you if it's colliding or not. And for me, it's not enough. I want to calculate the area, the overlapping, the coordinates of the overlapping pixels. And the Amiga hardware is not able to tell you this data. So I have to do calculation, but if I do calculation, it doesn't matter. I don't need the sprite collision detection hardware anymore. So this is another reason. So, but anyway,
did you do in the earlier episodes? Did you cover collision detection? No, you didn't.
Yeah, I think I did. I said something in the past about collision detection. If you look at all the slides, for sure, I explained something, how I detect a collision detection and how I solved the collision detection.
Yeah,
so
I need to go back then.
Yeah, it was, I think, at the beginning of February, maybe it was this winter.
I need to look it up. Okay.
Yeah, but yes, I'm pretty sure I talked about it. So
sure.
The TRK file. So if you remember, the TRK files are these big files with all these track data information, and each TRK file is just representing the image of the track, the metadata, and other information. I had to add an extra 1000 bytes in order to store information where the CPU should drive. So all the coordinates of the hotspots are now stored into the TRK file. They are at the end. And so I had to use 1,000 bytes extra of disk space, but still, since I have Shrinkler, I'm pretty comfortable doing this and also exaggerating. Even if I need less bytes, I want to take just a full 1,000. Another feature was quite easy to do it. It's the lap number, which is now selectable by the user. If you remember, we had this equation in the code. We had lap count equal something, so it was hard coded. Now you can just pick the number of laps that you want between specific limits. And then I found a very nasty bug, and it was about collision detection. And if we had time, I just want to explain how did I find this stupid bug, because as always, doing the routine is a matter of, let's say, I don't say hours, minutes, but finding a bug is very complicated on the Amiga.
Yes, yeah.
So I spent, I think, a whole day spotting this problem.
Sometimes something stupid.
No more features for now. You can show the game.
Yeah.
You can just go straight into the game without even passing through the options, and you will see that we should have 8 cars driving.
Yeah.
And in the meantime, I take my sip of water.
Let's see. There you go. So I have to click on it. Yeah. So do you need to select any particular option? Do you want to?
No. Go straight into start game and start race without passing through the options.
Okay.
Just to demonstrate the CPU routines.
Sure. And start race, basically.
Yes.
Okay.
It's a lap count of 1, so
yeah.
Just leave like that. It's a 1 lap game.
Which one am I? I don't know which one.
Nobody.
Huh?
Every car is controlled by the CPU.
Okay.
It's just to demonstrate that I was able to complete a whole lap.
I'm playing perfectly today. Not even I need to touch the joystick. By the way.
Yeah, but if you notice the CPU is really stupid, I think you can beat the Ferrari.
Yeah, when I tried it in the previous one, I told you what was the issue. Whoever leaves first always wins, basically. So, yeah.
Of course, you can, if you go through the option, you can play and control one of these cars.
Yeah.
And see if you can beat the Ferrari.
There you go. Okay.
So I was able to complete a lap. I'm very glad. So my primary goal was accomplished, I would say. And this is the final result. And the lap time expressed in frames. And then you should have the standings. So this is the game. And I don't know. We can continue with the slides, or you want to to compete?
No. I was just checking the game through all the things of the menu. So let's. So you should have the slides, and I need to turn the page. Yeah.
Okay, page number 4. And this is just a reminder of how the main concept behind this CPU. So this is just a slide from last week's stream. I just want to mention again how it works. I have this series of hotspots, and the car is just seeking the first hotspot. When the car is close to the hotspot, I just start seeking the other, so the following one, and until the list of hotspot is done. So he went through each of them. As I said, all these hotspot points are inside this TRK file. And the challenge for me was to instruct the car to drive toward this point just using the controls that are available for a human player. So it's just a human player substitution here. I'm not changing the car position with the coordinates. I'm just telling the car steer left, steer right, accelerate or brake, just like an artificial intelligence that ChatGPT nowadays is so trendy. So I'm trying to do my own ChatGPT. So I'm pretty done with this slide, and we can continue with the fifth page. Okay. This is, I think, part of the slide is hidden by my ugly face, but doesn't matter.
Okay. No, it's a sure. This is the whole page. What you are seeing? No. So here, do you see my? Wait. Let me show you my mouse. This is the last line that you have.
And I don't see your. Oh no, I'm the image on the top of the track is trimmed on the right. But it doesn't matter.
No, it's not. This is your. If I show you the full screen, wait, I can show you the full screen. You will see it's trimmed as it is also. If you see that, and I move this so that you can see here. Oops.
Oh yes, it's my fault.
Yeah,
yes,
it's trimmed from yours. Yeah.
I trimmed the image.
And I'm noticing you used dpaint.js of Steph. Yeah.
So this is another way of doing things because I didn't have my dpaint on the Amiga when I did this. I worked on my Chromebook, and there is this very nice dpaint like implementation at steph.be, and it allows you to work very similar to what dpaint is on the Amiga, and it just lives in a browser, so it's a web application, and it's able to save, to work, load, save on directly on IFFF files without converting it. So what I did, I just took my IFF image of the track, and then I started to paint with there is a pencil tool. I started to paint all these little points to the track, and every time I painted a position, I took a note, and then I copied the location because this dpaint implementation is also able to tell you the coordinates of your pointer of the mouse. So every time I click it, on this image. I took note of the coordinate, and then I just injected the values in this little bash script, which is on the bottom of the screen. This is not Amiga stuff, this is Linux stuff. It's bash programming, so it's a scripting language, but the point is I'm just appending each time the coordinates formatted in a word type, and I'm appending at the end of the TRK file. So the final result is that we have all this location at the end of the file. You can do it on your Amiga, of course, but I have my build system. I'm cross-compiling with Wasm from Linux to Amiga. So it makes sense for me to work in this way.
Is there some difference between the dots that are yellow, between the dots that are pink? And
yes, because the yellow dots are linked to a particular track section, because the track is divided into track sections.
Oh, yeah.
So in order to have a better orientation in the future, let's say I want to move a point 1 pixel to the right, I have to go through the list and try to find each time, compare the result with the image. In this way, things are a lot much easier, because each color represents a particular track section. So for example, I know that the first 1, 2, 3, 4, 5, 6, 7 dots are for the first track sections, and I only have to count the first 7 lines of my bash script, and I can locate the point much easily. But this doesn't reflect on some, let's say, usage in terms of the game. They don't offer any functionality. It's just my convention, and that's it. I could easily use the same color over and over again for each spot, no problem, because the game doesn't know, doesn't discriminate the color, of course. For the game, it's just a bunch of coordinates, and that's it. So it's just my convention in order to make things cleaner and easier to fix in the future if I want to change that data here. Okay. And so what I did, I just, let's say I'm terrible at drawing trajectories, actually, but this kind of points represents all the location where the car should point. So in order to complete a lap, the car should traverse and go through each one of these. If for some reason the car is dragged out of the trajectory, it must go back and find the latest hotspot that was reached and start from there. And if you notice in my demo before, this is what happened, because I think the one car was hit by another and went out of trajectory, and it had to go back a little bit in order to find the correct path. So this is the idea behind all this stuff. Another a problem with this approach is that every race is quite similar, so it's identical to another. The only element of randomness is the human player that can hit, for example, a CPU card, and this introduces some randomness. But if you start the game with all cards controlled by the CPU, the winner will be always the same card, because it's deterministic. A way to improve this could be, instead of having just a bunch of points, one trajectory, you could have multiple points for each location. So, and when the CPU has to decide which point to reach, you can use a random function. I don't know if it's we have a random function in assembler to use it. I wouldn't know how to do it actually, but yes, we could just take a random location from a bunch of 3-4
I
points.
can give you my random routine if you want.
What?
I can give you my random routine if you want.
It depends of what it's based on.
Raster.
Raster is not, it's pseudo-random. I need more randomness.
But raster plus other stuff. But raster is the main thing. But it is random. It is very random.
The important thing is that every race I have different result.
Yeah,
because
definitely.
It's only based on raster.
No, it's not raster
the same
alone.
Results.
No, it's not raster alone. But raster is it's raster, timer, and something else.
Yeah, this could be useful. It is another approach, but the point is, if we really want this, because I don't see players watching an 8-car race and all the cars are controlled by the CPU.
No, but
makes no sense.
No.
So for
but
me,
in games, the reason why I'm telling you is that because in games you always need randomness, no? So whether you do this game, whether you do some other type of game, you need some kind of randomness. And if this is a solution to what the problem of your problem, then yeah, you can have mine. I mean, I don't mind.
Yeah, actually, it's not always true because, for example, I have this game. I'm very addicted to this game. It's called Gym Power. It's a very popular game back in the days on the Amiga. And this game is deterministic. So if you perform the same exact movements in each game, you will end up always with the same result.
So it's not a random number, but it's random. You can have random tables also. So it's based on a pattern.
Yeah, but how do you generate random tables?
Huh?
How do you generate random tables?
Just take a high-level language, generate random values, and then use them in your assembly. As simple as that. I can tell you raster works if you use, let's say, you want the player to press the fire button. The randomness is generated at the time that you press the fire button. That is never at the same time. You can never get the fire button pressed at the same time. And that's how you generate randomness. On the Commodore 64 is used a lot, and you can use the same trick on the Amiga.
Yeah, this is a good catch. On my game, if you have a CPU car, the CPU will press fire for you because it's acting like a human
but if
player.
you do it manually, a human being can never be accurate to the nanosecond or microsecond, whatever they use.
Absolutely.
So,
this is a good catch. I can say to the game, wait until one of the human players, so if it comes from the joystick or from the keyboard or from the parallel port, you just start the timer there and then you get the VH pause, for example.
Yeah.
This is a good approach.
Yeah.
I completely agree. Yeah, this is a possible solution, a possible implementation. And yes, so I think we can go on to the next slide so we can see how the new TRK file. This is the composition. I'm trying to write some documentation in order to let people or me in the future add new tracks. And
I want to ask you, so how many points do you end up with in one track? Because it varies. It should vary according to the track, no?
Yeah, I wrote the answer here in this slide.
Yeah, but what I mean is, let's say in this one, you took. I see that you have 250 positions for each track.
This is the maximum allowed.
The maximum allowed, but does that cover? I mean, if you have a complex track or Is that enough, you think?
If the track is complex, you still have maximum 1000 bytes in order to
Okay, that's how you
represent
did it.
all the
Okay,
points.
okay.
So the size of the TRK file is fixed. It has to be exactly this size, and it has to be, the offsets must be very accurate. So there are fixed points, because my read routine will just go to this offset and load into memory at predefined labels. So there is only one way to make this work. And what I added, it's at the end. And I said that at byte 100 to 124912, so this is where the offset, you can start defining the points. And from here, you have to fill 1000 bytes. And this is a completely arbitrary number. I can extend in the future if I need, they are not enough. But for now, it's good. And
Well,
in order,
if you have 1000 and you only use 250, I think you are quite safe.
Yeah, in order to represent the positions, the maximum allowed position, you have to divide by 4, because each coordinate takes 4 bytes along. So 2 bytes for the X position and 1 byte for the Y position. Actually, I could shrink, because the image height is only 240 pixels, and you can represent this number with only 8-bit. But just to have things simpler from a coding point of view, I decided to format in words. So each number is represented by an unsigned word. This makes XY 4 bytes. If you divide by 4, you get 250 points, positions. And this is the maximum allowed that you can represent. You have to subtract 1 position, because I need to know, so the program needs to know which is the last point. Because when you reach the end of the lap, I must reset to the first point in order to let the car perform another lap. If your race is multiple laps, for example, 2 laps or 3 laps, I have to a way to know, okay, I have to reset my pointer. And this the data that is telling me that I reached the last point is this marker. It's very similar to the end of a copper list, even if it's not the same, but the concept is the same. If you put FF, which is a position that can never occur because the height of the image is 240. So if you reach this particular value, this means that you are at the end and you reset the pointers and you start over from the first hotspot. And this is how it works. And I think it's a quite good solution. I don't know. Of course, it's a little bit of waste of bytes, but since I have plenty on my floppy drive to spend, thanks to Shrinkler, why not?
Yeah.
Okay, so let's go to slide number 7. We can start talking about code.
Yeah.
And this is my routine for hotspot detection. And while I was developing this, I realized that I couldn't. It was better to not to be so strict about the rules, because initially I said to the engine, whenever a car reach the hotspot, you just update the pointer and go to the next hotspot. And this is a problem because the car doesn't really get exactly to that point. It always gets near the point because it depends. If you are traveling, for example, 2 pixels per second, probably you won't hit exactly this, this spot.
Yes. Yeah.
Another use case is if the car is hit by another car and goes slightly off trajectory, it will just go to the left of the spot of to the right. So it's very likely that it will never reach the hotspot. And when this happens, you see the car goes back for apparently no reason, in order to find exactly the same point.
Yeah, we saw it last time, no? That it tried to do that. Yeah.
Yes.
Yeah.
And this is a problem for me. And what I did, I introduced this concept of CPU next point threshold. And this is just telling the game engine that let's think about this hotspot is not a point, but is a circle, and the center of this circle is a point. So the goal is whenever you enter, you touch this circle, you reach the hotspot, and you can go to the next one. This is the point. And the way I implemented that is the following. I compare this threshold, which is arbitrary number, is equal to 20. And I compare with D1, and D1 holds the distance between the car and the hotspot. If we are too far away, we jump to the destination not reached label. Otherwise, we from the first move queue, we are dealing with a situation when you reach the hotspot. And when this happens, I want the car to keep pressing the acceleration button. This is what move queue 4 into the 0 does. It just sets a bit that tells the game engine the car must accelerate. Then A5 holds the pointer of the hotspot of the coordinate system, and I copy this address into A0, and I check if the content of this address is this FF. And this means, as I told you before, that the next point is the last one. So we reached the end of the series of points. We have to reset. And this is what the move.l mover destination into A5 does. It just pushes into this address the address of the first point in order to reset the game, to go to the first hotspot. If we are not at the last hotspot, I just say this is not end of track label. I just go to the next one, and since a coordinate is made of 4 bytes, I just add 4. I think here could be optimized with add q, because if I remember correctly, add q is able to increment directly on memory. It doesn't require a data register.
Yeah.
But yes, this is a little optimization that I could do. And that's it. This is the concept behind how should I consider the car, when I should consider the car moving to the next hotspot, when I'm considering the hotspot reached, how do I reset the hotspot when the lap is done? And so all of this was expressed, implemented in just these few lines. And I don't think I'm not using diffs, I'm not using mults, I'm not using strange black magic.
How did you calculate the threshold though?
The threshold is fixed. It's 20. You see, it's the first line.
No. You said if the magnitude is less than the threshold, but the threshold varies by each point, no? What is the threshold? How did you come up with the threshold? No?
The threshold is a fixed constant.
Yeah, but the threshold has got plus, minus.
No, it's not plus, minus. It's just 20. This is the threshold. D1 is the element which is changing over time.
I'm trying to imagine how you did the routine, so that's why I thought you are using negative and positive numbers, and then depending on.
I don't see any negative number.
No.
D1 is the magnitude.
Mm-hmm. Okay.
And the magnitude of a vector should be greater or equal 0. You can't have a negative magnitude. It doesn't make sense.
No, you cannot. No, you cannot. You're right. No.
So I'm just saying D1 is the distance between the car and the hotspot. And then saying, okay, if you are closer than 20 points, 20 pixels, then you go inside here and you check if you are at the end, and if not, you just go to the next hotspot. That's how it works. I don't know if I...
I think you are clear. It's just me, because I was trying to imagine the routine before this one, how you are writing, but yeah, okay, fair enough.
Yeah, remember that how I calculate D1 is explained on the last last stream. It's all this math. It's
I remember the magnitude. I remember the magnitude thing, and I'm just thinking. Yeah. Okay, fair enough.
I will say the hard part was all the math that we did before when we did the seeking algorithm. Now we have all the data, and we are just giving the rules of the game. So if you are close to the point, you consider it reached, and you go to the next one. That's the point. Okay. We can go to the 8th slides, and this is another problem that I had, and it was solved in this way. It was about break detection. And let's say that we are at full speed and we are approaching a hotspot, and the next hotspot is very far from the optimal trajectory. So, for example, if we have a very steep curve, in this case, are you listening?
Yeah. Continue.
Because my video is freezed.
No, I'm fine.
Okay.
No. It's
okay.
All good.
For some reason, I don't know, my Twitch stream was freezed, but yes, now it's good.
Yeah. What browser are you using? Are you using what I told you to use?
No, I'm still using Chrome. I didn't have time to check.
Okay, fair enough.
The Brave browser, I think.
Yeah. Thanks to Dockster, he told me to use Brave browser, and yeah, it does work. It does solve the problem.
My problem was not the advertised this time. It was just stuck. The player was stuck for a brief moment. So anyway, back to our talk. The problem is, let's say that we have a very steep curve. If I keep saying accelerate all the time, so keep accelerating, you are traveling at max speed, and according to the rules of the game, you will end up crashing into a wall or something. So my goal was to make this intelligence less dumb and say, okay, if I see that the angle between the 2 points is bigger than a certain threshold, please do not accelerate. You just turn into the new hotspot without accelerating. And instead of accelerating, please brake, because otherwise you will end up crashing in some obstacles on some wall. This is the problem I was trying to address. Because if you don't do this, there is a very high probability that the car will be stuck at the wall, trying to reach a point which is behind the wall. And since the computer is very dumb, it has no way to detect another path.
Yeah.
So what I did here, I declared these two constants. That is CPU angle threshold, which is the threshold that I was talking about before, and the brake velocity threshold. This is saying, okay, we have a very steep angle, but you are moving very slowly for some reason. Please don't break it, because otherwise you will end up moving to a velocity 0 and you will be stuck forever. So the combination of these two parameters should help the car to understand if it's the case to accelerate or to brake. This is the problem I was trying to solve. And in order to solve this, I did this little macro, which is called the between U word. It's just telling you, given a number is in a data register, is telling you if it's inside the range or not. And in this case, I'm just checking this CPU angle threshold. If it's between the CPU angle threshold and 360 minus CPU angle threshold. If this is true, so the output is inside D1. If the D1 is not equal, I go to not break, because this means
so between you where there's a macro that you wrote.
Yes, it's inside AProcessing.
Yeah, okay.
Just a few instructions. It's not a big deal.
Yeah.
I'm just using branches in order to understand if a number is between a range.
Yeah.
And this is the U-word version. It means that the comparison will be performed using unsigned branches and on 16 bits values, because that's the format that I'm using. And the point here is, if this D1 is true, we are within this range, and this means that the car is pointing more or less at the right direction. We don't need to brake. You can just keep steering and accelerate. If it's not, just brake. There is the bset 3D0 is telling to brake, and be clear, it's just telling, please, you don't accelerate, because there is this awkward state that you can specify in my game, because if you press accelerate at the same time, and at the same time you press brake, the two vectors are additioned together, but the result will be 0, so it's no effect. And this is why I tell the CPU, please pick a state, or whether you brake or you accelerate, or these are all my only two states available right now. And this is how I solved the problem. It's not perfect, of course, but it's very useful. For example, when the car is on ice, for example, there is a high chance that you go off track of the ideal trajectory. And in this case, the CPU is smart enough to understand that's the case. It's better to brake and reposition the car, pointing the car to the right hotspot, and when you reach the correct orientation, press accelerate again. That's how it works. And this is what this little snippet of code is trying to achieve, more or less.
Mhm.
And the last slide, then another problem. So slide number 9, I think.
Mhm.
And this is horrible. I know that you will scream seeing that. Car stack detection, teletransportation. Even if I took these measures, there are still some corner cases
I
when
like
the
the
car...
image that you selected.
What?
I like the image that you selected.
It's just taken from the web.
Yeah, but
But so the problem was trying to solve this time is the following. Even if I instructed the CPU when to brake, where to brake, how to correct orienteer the car into the space and whatsoever, there are still some corner cases when the car is stuck. For example, there is another car who is pushing the car towards a wall, and we end up on this dead loop, and there is no way to get out easily. Actually, I had something in mind, but it requires further calculations, so this is not something that right now I'm willing to solve. So, quick and dirty way to finish the game, because remember, if one car is stuck in some point of the track, there is no way to finish the game, because the game ends when all cars crosses the finish line. That's how it works. So if one car is stuck endlessly, the game won't never finish. You are forced to press ESC or reboot your machine, and this is not good. So how do I solve this? Simply teletransportation, because we are on a world of pixels, and the programmer is the god of this world, and the programmer can do whatever he wants. So what I'm doing right here right now, I test if the mover is the car. So I test if the mover is colliding or not. If it's not colliding with anything, everything is good, and there is no way that the car can get stuck in any way, as far as I know. Then, if it's colliding, we have a problem. We have to resolve the colliding. Maybe we are hitting a wall, for example. I don't know. In this case, we use a counter. I implemented a counter, which is a car property. So we have a counter for each car, and I start counting. If the car is freed before a certain amount of time, this counter is reset. And this is what happens in the last line. When I say move.w 0, mover CPU consecutive collisions A2. Here, I'm just resetting the counter. If the car is really stuck, when we reach 100 frames, I think this is the threshold. If the car is colliding for 100 frames consecutive, and it means probably that it's stuck. And if it's stuck, we have a problem. You have to solve it. And how do we solve it? And it's written into I think it's in the middle of the snippet. There is a section when I say move.w d1 mover x position offset a2 and move.w d1 mover y position offset a2. Here I'm just pushing and forcing the car coordinates to have the hotspot coordinates.
Yeah.
This means that
I'm
the car will
curious.
teletransportate to
I'm
this location.
curious. I'm sorry, I'm interrupting you, but I'm just curious. How did you come up with the idea? Because it would never come to my head to count, to check the frames that when a car is stuck. I would be I would really be thinking and thinking and thinking how to solve such a thing. And this has a, I don't know, has struck me.
Yeah, while I was running my tests,
Uh-huh.
it occurs a very particular situation. So for some reason, a car hit the wall.
Mm-hmm.
And of course, when you hit the ball, you start bouncing on the opposite way.
Yeah.
But right after this car behind, there was another one. And it was pushing this car again through the wall.
Uh-huh.
And then another car comes and it's pushing the other car, which is pushing the other car to the wall. So this is a corner case, and I don't know how to solve easily. Well, I had some ideas how to solve it, because I have sensors, for example, on the tires of the car. I can understand if the car tires are colliding with an object, and if the object is the scenery, if the object is another car, and
Mm-hmm.
so I have a lot of information, and I can extend my algorithm in order to say, okay, you can't go forward, but maybe you can go left, maybe you can go right, you can go backwards. So thanks to all these sensors, I could probably try to solve this problem, but this adds complexity. And this is not something that I'm willing to do, and this is not something that I can do in a very short time. And above all, it's quite boring. Let's say I can do it in the future when the game is finished. Maybe I can release a 2.0 version that solves this problem. Right now, for me, the quickest way to solve this is just forcing the coordinates of the car, replacing them with the hotspot. So since the hotspots are very close to each other, you see that the car have this little teletransportation, which is okay. The gamer, the user can for sure can notice this, let's say, cheating, because the CPU is cheating. But yes, it doesn't happen so often, but it happens. And still, this is something that lets you finish the race.
I would have not thought about counting the frames. That is impressive. For me, that is it would have never came to my head to count the frames that when a car is stuck.
This is mandatory, because you can't say, if you touch something, please teleport. This is cheating.
Yeah, of course. You cannot do that.
Cheating.
But it would never
if you
come.
keep hitting the wall, and the 100 frame is about, I don't know, 1 second.
One and a half second. One and 3/4 of a second, no?
Yeah. It means probably that the car is stuck. And for me, it's fair to say that in these seconds, you probably, in normal situations, you would have reached the next hotspot. So and you lose time, so there is a penalty if this happens for the CPU, but still you don't get stuck.
Yeah.
And makes sense to me. Okay,
no,
it's dirty.
It makes perfect sense, quite a bit. It's just that I would not have thought about it, but yeah, good thinking.
Well, when you are looking for a quick way out, your brain starts thinking. And
good thinking.
Since, as I said, the programmer is the god of this world. So if the programmer wish that a car is teleported, it could happen. So this is the main concept behind this. And if you start the game, for example, on track number 2, there is, and if you set the lap count to 8 at least, if you remember, there is a point in the track when there is a crossroad. And since the game so far is deterministic, I remember that at the last lap, 2 cars are hitting into each other because there is this crossroad.
Yeah.
And one of these 2 cars is pushed out of trajectory a lot, and it's not able to recover on its own. He needs this routine. Without this, it will be stuck because of this crossroad.
Okay, so we should maybe do the test. I mean, if we have time. I mean, I don't know.
Yeah.
And
just
do a test of, I don't know, 10 laps and see how they behave.
10 laps are not possible right now. I set
No?
the limit to 8
Okay,
for some reason, because 10 laps are too boring.
Yeah,
But you have to pick track 1.
Yeah, it's just for testing. But okay, let's continue, and then we can test it out if we have time.
There is only one slide left, and then we can run the game again.
Okay.
If you want. Okay, so go to the last slide, which is about my bug, and it took me a lot of time to spot this bug. And it's a collision detection bug. So I started, in order to test my algorithm, what I did, I said to the cards, please go endlessly, so run endlessly until I reboot the machine. And sometimes I noticed a very strange thing. I saw a car which was teleporting from the extreme left position of the screen to the extreme right position of the screen. And my first assumption is, okay, I just wrote a routine that does the teletransportation because of the stuck car problem. So probably there is a bug here, and I wrote this routine not in the proper manner. So I started investigating the routine that you saw on the previous slide, and I said, come on, this is good. This is doing what I want. It's not possible. So what I did, if you know, there is the possibility on FS-UAE, but also on WinUAE, to save a state. So if you press F12, for example, the emulation pause, and you can save the state. So the emulator stores internally the status of the CPU, of the RAM, of the cout interrupts, or whatsoever. So I went exactly at the frame where the car was teleporting, and I started debugging. And what I saw, it was this. This is a part of my collision detection routine. And you see that there is this sub 2D vector static. And here I'm calculating the distance between 2 cars. And I'm just stating, if the distance is less than something, probably the 2 cars are colliding and you have to resolve the collision. In order to understand what is the distance between the centers of the car, I just subtract X and Y. The problem is that the Amiga has 320 pixel width on screen on low power res. So if you compare, for example, a car which is on the left, on the very left of the screen, with the car which is on the very right of the screen, and since I'm reserving the last bits for the decimal part, you end up with a very big number. And if the most significant bit of this word is set, the branching is affected. What I'm doing here, I'm using ble.w in order to branch if it's less equal, I think.
Mm-hmm.
But ble is a signed comparison.
Yes, I
So
was
it
going to
means
tell you.
that if the distance is so big that the most significant bit is set, this BLE will treat this number as a negative one. And so the comparison is wrong. In order to fix this, I just switched to the correspondent unsigned version of branching, which is BLS. And this is how I fixed that. So this was the problem, and this was why I saw sometimes the car teleporting.
Mm-hmm.
And this bug was there for months. And it never occurred to me because it happens only if the X distance between two cars is so big. So one car at the extreme left and the other is on the extreme right. If the car distance is so big that we have this bit set, we have this particular situation where we have a wrong collision detection that causes the teletransportation. This
thing of the signed and unsigned branches, I was caught many times in it, because in games you use these things quite a bit, and I ended up with a table, which I actually shared in my streams related to the 68,000, where I say which instructions of the branch instructions work on signed and those that are unsigned, and I suggest not to use the unsigned ones the signed ones, unless you are using those complement, because they really can cause you issues.
Of course. And after that, I'm wondering if it's better to print a list on real paper, print all the mnemonics of branching and stick somewhere here in the wall, just I can have
it. I do not have it. I did have it, but because I changed the layout of the room, it's not here, but I did have it. But I do have, I shared the table. I shared the table with, when I was doing the streams of learning 68K with Dockster. So yeah, it's a very important thing.
Yeah, make an artistic print out of it and sell it on eBay, and everybody will buy this for coins.
Actually, that's not a bad thing. I mean, not sell it on eBay, but make like to print it on a Mac or something, so that you remember it, because it's.
Yeah, I can say even if I program in assembler quite regularly for years now, still I don't remember if BLS is signed, if BLE is signed or not. So sometimes I'm just slack. I don't have.
No, I do go and check them nowadays.
To check, I just put whatever comes first.
No, I do check nowadays. When it comes to these, I do check, because I felt when doing games, I fell too many times in traps related to this. So yeah.
And this slide is just a reminder for anybody who does assembly programming on this processor. Please always don't do like me. Always think if you need the unsigned or signed version. Yeah. This is a strong suggestion, because if I had think about this one more second before writing this code, I would have saved my whole Sunday.
Yeah,
probably.
If you're not using signed numbers, don't use instructions that use such a thing.
Yeah. Again, the magnitude of a vector is something that is positive, so you have to use unsigned. In this case, makes perfect sense.
Yeah.
Since I'm expressing all the magnitude with positive numbers, and I'm just comparing to unsigned numbers, I have this problem with the huge numbers. So this is, let's say, hard to spot because it's random, and when the problem occurs at random times, so you don't know what to do. And this is why it took me so long to understand this problem. And so yes, this is just my little advice to consider always the signed unsigned version of branching.
Yeah.
And okay, I think I'm done with the slide. If you want, you can run the game again and see the teletransportation in action.
Yeah, I'm going to do that.
And this time, follow my instruction in order to reproduce the problem.
Yeah. So where shall I go?
You go to into lap count, and you set to 8.
Mm-hmm.
And then you start to race. And if I remember correctly, at lap number, you can pause the emulator, right?
Yeah. Well,
okay.
F12, no?
When we are at lap number 5, for example, just pause and save the state.
Mm-hmm.
So you can, if you don't notice the first time the teletransportation, you can rewind and watch it again without watching the first 5 laps. And I think the car which is teleporting is the green one, the Alfa Romeo.
It's interesting.
Lap number 2.
It's interesting how.
Also, I noticed that the blue car is almost the same color of the cyan one.
Yeah, well, yeah.
And I'm planning to replace this color with a yellow, because the Renault for me must be yellow.
I think either you make the colors of the cars more brighter, or you make the track, because sometimes it's not so visible, the car on the track. I don't know if you have noticed that.
It can happen because the colors are shared, but for me,
no. But
right
the colors
now
of the. But you're talking about the colors of the sprites. I'm talking the color of the track, the gray against the cars. So because the cars has also gray in them.
Yes, the outline of the shape is gray. This is a known problem, and I didn't solve it because essentially I can't include these tracks on my final release because they are not mine. I will need an authorization from Fabio Antoniazzi, which is the original author of this track. And so since these tracks are gonna be replaced, hopefully Carlo will paint 1 or 2 for me, I hope, from here to October, or my daughters.
Look, it's here.
You saw the cyan one was teleported.
Yeah, I saw it. Yes, it was teleported. Yeah. So that, because I haven't used this feature for a long time now. What is it? Outputs? Is it output? No? And
on FSUOE is F12, and then menu on the right pops up, and you select save state. On UAE, I don't have a clue.
Yeah.
But it should be possible.
Yeah, it is possible. I just haven't done it for some time. Anyone in the chat that has done use save state in UAE? I haven't done it for some time, I'm realizing. Can't remember.
It should occur again at lap number 5. So it will be good if you can save the state here.
Yeah. Because you see, there are states is here. So the directory is configured, but where to do it? I forgot. I completely forgot.
Actually, I'm just seeing my track on the stream. I'm not seeing the WinUI configuration.
No, you
window.
cannot. You can only see. Yeah, yeah. To do that, I need to change the screen. I need to do this. Now you see it. But I really don't remember. I really don't.
Using save states, press F12, select miscellaneous under hosts.
Miscellaneous hosts.
And then select, click save states, and there is a button on the right.
I'm not seeing. Are you seeing it? I mean,
yes, I do.
Here. Okay, save state. Okay, yeah. And
I don't know. And there is a load state next.
Yeah. So save state. Let's do it in the somewhere else so that I find it quicker. And let's say Ozzy, and this is track number 4, no?
Yes.
Save.
It's lap number 4.
Yeah. Okay. We saved it. So okay.
You can just continue and pay attention to the green car. It should teletransport as well. Yeah, the red car was the okay right now.
Yeah.
Did you see it?
No, I didn't see it. So
you can just reload the state. It just happened.
Yeah. Shall we save another state?
No, just load the old state.
Okay.
And pay attention to the corner at the bottom left corner, lower left corner of the screen.
It's something is wrong now. I didn't like it. It didn't like it.
No save state.
Well, I did save state. Look, load state, and I selected the one.
It's paused. Come on, in the title screen of the Windows said it's paused. The emulation is paused.
No, now it's paused because I went I pressed F12. But as soon as I tell it okay, look, they're trying to move, but it's like no, it didn't like it. You see, it's trying to go. They move a little bit, the cars, but nah.
I don't know what to say. This is
well.
It works on FSUIE. Now it's not working anymore. This is something to report to Willem, to Tony Willem.
It's strange. There you go. It continued. Boom. Did you see the teleport? I saw it.
Yes.
Yeah. Okay.
It can happen.
Yeah.
Don't
Okay. I
worry.
saw it. I saw it.
You can mitigate the problem if you insert more hotspot in this particular location of the track, and it should solve the problem if you add more points because you have more accuracy. But still, there are some situations when you need teletransportation, and this is why I decided to implement it anyway.
So I'm curious how the cars will come. Yeah, but the first one always wins. Always.
The first one always win unless you play, because you are an element of randomness.
Oh yeah, of course, yeah.
The Ferrari always win here.
And not in real life though.
Not in real life, yes. Usually Alain Prost is the winner. Always, I would say. If I remember correctly, Alain Prost is always the winner.
Okay.
And the last one is always the Alfa Romeo, I think. But anyway, with a real human player, this could change. It just needs some randomness.
But one thing that I'm noticing, reds, well, now it's swapped with cyan, but reds, then there were greens a moment ago, and now there is cyan splitting them, then there is blue. So look, they are taking again the shape, what I just said. Look, two reds, greens, no, two cyan, but the green is dividing them. But yeah, it's also because these are, you can tell now, these are the sprite pairs. So yeah, we have two reds,
two greens, two blues, because we are working in teams, so we can do a constructor championship if we want. Actually, the color is recycled for obvious reason, because the sprites comes in pair, and each pair shares the same palette. This is why I had to do like this. If I want to use sprite, and if I want to do 8-car game, this is the only way, unless I use AGA.
Or you change those cars into bobs.
Or I change this car into bobs. Yes, this is another possibility. But for me, there is, we can do it, no problem. If you do this, you have to paint over 5-bit planes, and it can be a problem because you have to extract with the blitter, you have to extract the background and repaint this, and do for every bit plane. So it could be problematic.
You don't need to go every
performance point of view.
You need to change the format of the images also, because you will need to use interleave, else you'll be going every bit plane, which is time consuming.
For me, this is what I designed, and this is playable for me. It's the way to go, because with all this raster time that I save using hardware sprites, I can use to implement other things like CPU car controlling, collision detection, and all this stuff. So this is my pick. But of course, the project is free. Anybody can implement bobs if he wants.
No, I'm thinking that I think you will still be fine even if you use bobs, because
they are so small.
They are so small, and to be honest, you're not even using 16 width, so you will have, it's not worth it using bobs, because you are not.
I'm using 10 pixels, so anyway, I have to use a word, and the blitter works in word.
Yeah, but
so I'm
when you
moving
blit,
5 words.
Yeah, but when you blit, you have to. You always have one spare word, no? So if your sprite or your bob is one word, that means you have to split two words. But yeah.
Yeah. But yes, but this is doable, of course. This is doable. Doesn't make sense on, for example, on higher specs Amigas. For example, I can use just the processor in order to draw. This is another option. What I had in mind in the past is to release an AGA version that uses this approach. So I can add more colors and I can use mobs instead of hardware sprites, or or take advantage of the new sprites offered by AGA. Another approach would be rewrite the game, just replacing the routines that are meant to draw something on the screen and use the RTG graphics as the cyber graphics. A lot of things can do here, but right now I'm just focused on finishing the game before October. This is my primary goal.
I do not agree with this theory of yours, but yeah.
Which
I will
one?
tell you after. That you set a time limit when you finish a game. I think you finish a game when you finish the game, not when
No,
you...
because this time I want to help Carlo with another project.
Yes,
so
you can, but it doesn't mean that you don't look at it at the same time, because it's the final
No,
touches.
it's impossible
In
for
games,
me. I need to focus on one project at a time.
But in games, it's the final touches that count, and that is the...
Let's say
I
it's
made too many
possible.
times this mistake.
It's possible that the game will be freezed in October. I start doing something else, and then I can resume working on that.
Yeah.
This is another possibility.
But one thing, what I wanted to say is, by experience, I'm telling you, because I fell into this trap many times. It's if you do 90% of the game and you say it's finished, but that 10%, you've struggled to finish it, to finish completely, and that's 10% is what makes the difference in the game. So yeah. Anyway,
yeah,
it's my personal opinion. Yeah.
Your position. My problem here is that it's not a problem actually. Is that the coding part is, I would say, 19%, 90% completed. So
Yeah.
the game from the coding perspective is almost finished, because I implemented all feature that I had in mind when I started back this autumn, the last autumn. So I'm quite satisfied with the final result, even if it's not a AAA game, of course. It's just a little game to have fun. So the coding for me is essentially done. What I'm trying to do from here to October is just to add some audio assets, maybe some little feature, rework the HUD, some final touches. The biggest problem for me is still that even if I had some help from Carlo, still I'm missing the track images and I'm missing the music assets. So these are the big lacks of the game from my point of view. And I'm not able to do this because really I'm terrible at drawing. I tried. And for me, pixel art is a nightmare.
Yeah, I understand you. I have the same issue. You can see it from the game that I'm doing, that it is a big issue for me. And I cannot, let's say I'm struggling to get the graphics. Let's say that.
And thanks God, at least I had these gorgeous background images, because without Carlo, the background on this screen will be completely black. And in the fonts that I would have used the fonts that were used by Ramjam from the book, because I don't have any other font.
Well, I use the same thing, to be honest. I use the same, because it's I do have other fonts. I just was lazy and never went into changing it. But yeah, I'm sort of got
Um,
used to that font. Let's say that.
Another thing that is missing is the documentation for releasing the changing the car sprites, for example, how to compile, how to make a new track on your own, and above all, this is missing, and the instructions how to build your own
Yeah,
box with the serial box that you find at your grocery store.
yeah. Yeah,
And
that's a good point.
I want to include all this information inside the floppy disk in Amiga guide format.
Uh-huh. Yeah, that's a really, really good touch. I like it.
Yeah, this is what is missing and what I will try to do from here to October. Then, as I told you, I will switch back to the demo scene because it is more attractive to me, and this is because I have something in mind with Carlo. And then after we release this product, let's say this demo disc with Carlo, I can go back here. My plan will be to redo the game, make it better, and do an RPG version if I understand
Really?
how
Okay.
cyber graphics work.
Interesting.
And of course, you have to provide me a setup in order to stream an Amiga on RPG.
I do have.
If you have it, good.
Yeah, I think yeah.
And we will start again with the first stream, and it will be draw a point on our RTG screen. Because if you remember, at my first stream here was I will show you how to draw a point.
Yeah,
and
the only thing is RTG. There are two types. Well, I don't know if you're talking about using the Picasso tool way, or you're using the what is described in the book of Remgem, because or of Fabio. I don't like saying Remgem because the book is of Fabio. If you are referring to that, because
I just want to use a chunky screen. That's the goal. It doesn't matter if it's
so you want
Picasso.
you want AGA and the chunky screen. That's what you're saying.
No, I don't. I want a chunky screen. AGA is planar screen.
No. You need an Amiga 1200 because the Amiga 500 cannot do that.
Amiga 4000, for example.
Yeah.
Nice.
From the Amiga 1000 upwards can do what you're saying, but not the 500 or 600. They cannot do that.
Unless you have a vampire or a pistol.
Or a PyStorm, yeah. Unless you have those, yeah. But I'm talking standard Amigas.
Unfortunately, my vampire broke down again. Actually, not the card, but the real 600. So I'm stuck from this point of view. I have to rely on emulators.
No, I guess we are finished, no?
Yes. You. Yeah. Let's say no more topics for today.
Okay, so guys, I thank once again Ozzy for all the stuff that he did so far, 12 episodes on this game that he is building. I think, me personally, I also learned a lot from these streams of Ozzy. He has different views than I, and it's good to see the different views, which is a good thing, because I do not have many people with whom I can talk and share my views in related to game development.
Me neither.
So yeah, it's quite a good thing. Anyway, thank you very much. Thanks back to the bit for the cheer. See you guys. I'm about to raid. See you guys. Bye bye.